All right, problem number 7, another graph where we're asked to write the domain and the range. So here we go. A reminder that domain is a list of x values and range is a list of y values. How do I remember? D comes before R in the alphabet, X comes before Y in the alphabet, so they kind of match up in that way. That's how I first remembered it back when I was in high school. So if that helps you, awesome. So let's do that. So the domain is all the X's. So it's going to be all the X's. So let's put an X in the middle there. And X's go from left to right. So let's start by looking all the way over to the left. All the way to the left. What is that X value? That X value is at 1. So the smallest X value on this graph is 1. So the smallest X value will go over here. And it goes from left to right. So now let's go all the way over to the right and find the biggest X value. So the biggest X value on this graph is 7. So all of the X's, so the domain is our way of saying that it's the X's which go from 1 to 7. That's where you can find the graph. We remember from Unit 2 that when we have an in-between situation, so it's all the X's that are in between two numbers, we always make the inequalities go that way. Again, these are both filled in circles, so we will put the line underneath. And now we're going to go on to the range, which is the y values. So range is going to be the y values, and the y values go up and down, right? So let's go down, and we'll put the lowest y value over here. So down, 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 down. This is the lowest y value right here. That's at 2. So the lowest this graph gets is 2 when we're looking up and down. What is the highest this graph ever gets when we look up and down? Up, 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 up. Okay, right there. So that is at 6. So the highest this graph ever gets is 6. Again, inequalities go this way. These are both closed circles, so we'll go like that. Is it discrete or continuous? Once again, in my mind, the way I remember it is that discrete is when it's a bunch of dots, and continuous is when it keeps going. Again, they kind of sound the same. Discrete, dots, continuous, keeps going. On the last page, we saw an example of one that's a bunch of dots, dot, 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 dot. So that one was discrete. But on this page, we see that this graph keeps going, keeps going, keeps going, keeps going, keeps going. So that one is continuous. So we're going to circle continuous for that. And that's how we do problem number 7. Great work.